Welcome. The rational zero theorem you've used already in the last section. And this is the one that says if you have a polynomial, let's say it's 2x to the fourth power, and then all this other stuff with, say, 16 on the end of it. Okay, say plus 16. You can find the real zeros, the possible real zeros, comes from a group that's the factors of P over the factors of Q. This is Q and this is P. So for 16, the factors of plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, plus or minus 16. And then for Q, it's 2, which is plus or minus 1 and plus or minus 2. So you basically make all the possible numbers you could. So 1 over 1 and negatives. So you have plus or minus 1, and then 1/2 and plus or minus 1/2. And 2 over 1 and 2 over 2 is 1. So that's already taken care of with the 1s. And 4 over 1, 4 over 2, 8 over 1, 8 over 2, 16 over 2. So the set of possible answers are plus or minus 1, plus or minus 1/2. Probably should put the 1/2 first, because it's the smallest one. And then the 2 over 1, so it's plus or minus 2. 2 over 2 is covered. 4 over 1, plus or minus 4. 4 over 2 is 2, and the same with the negatives. And then plus or minus 8. 8 over 1, 8 over 2 is 4, plus or minus 16. So there are 1, 2, 3, 4, 5, 6. There are 12 possibilities there. And if there are any real zeros in this polynomial, those real zeros would come in that group of 12 that are shown here as the solution set. Now, let's use this to our advantage in this application problem. Okay. Really nice geometry application. Get a great opportunity in polynomials to work with geometry here. So we're going to look at the volume of a rectangular solid, 330 cubic feet, which is feet squared, or no, cubed, I apologize. It's cubed, and I have the 3 there to prove it. The width is 6 feet more than the length. And the height is 5 feet less than the width. Find the dimensions. The dimensions are going to be the length times the width times the height or the depth. We'll call it height. Let's go back there and call it an H. Right, so we could draw this out, a rectangular solid, sort of like this. And the numbers won't quite match here, but this would be like the width or the length, or this would be the height, length, call it width or length, doesn't matter which one. The height's usually up or down kind of thing. So we need those 3 numbers. And if you multiply them, they make the volume. Because when you multiply these together, that equals volume. So what we're going to do here is think about using this information. Width is 6 feet more than the length. Height is 5 feet less than the width. So looking at that, what we need here is that the length be, say, x. And then the width, in fact, let's do this out here. I'm going to use black now. If we make the length x, that means the width, let's write that better. The width is going to be 6 plus x, and then the height is going to be 5 feet less than that. So it's going to be the width minus 5. So the width take away 5, but the width is 6 plus x minus 5. So that means that 6 minus 5 is 1. So that means it's actually the height becomes x plus 1 or 1 plus x. So all of that was used to get x plus 1. Okay? Or 1 plus x, doesn't matter which way you call it. So now what we would see here is that the volume equals length times width times height. So the volume of 330 is equal to x times 6 plus x. I think I'm going to make it x plus 6 because I'm just used to putting the x first there. And then an x plus 1. We have the beginnings of a polynomial that we can multiply out here. Except we'd need to solve for these. We have to make the 330 a 0 over there. So what we have to do is multiply out this side. Okay, so I'm going to get x, multiply these gives me x squared, plus 6x plus 1x makes it plus 7x plus 6. And then 330 equals x cubed plus 7x squared plus 6x. And we're going to bring the 330 to the other side, and we have our 0. Plus 7x squared plus 6x minus 330. Well, what we now see is we have a q. I'll make it a capital Q this time. A q here of 1 and a p of negative 330. So our possible solution set numbers, oh my gosh, we're going to have a lot because plus or minus 1, well, 330 would have a plus or minus 2 in it. Would also have plus or minus 3. I don't know, 4 would go into it. I'd have to start playing with it. Then I'd have 110. I'd have plus or minus 330. And who knows how many others. But you know what? I'm just going to start with some of the basic ones here. Although, let's think about it now. Let's come over here and think about what possibilities are here. Because I don't think 330 would fit in here as a possible length, width, and height. If these have to multiply to make 330, let's think about numbers that would work with them. Okay? So if I were to put, say, 1 in here, I'd have 1. 6 plus 1 is 7. This would be a 2. 2 times 7 times 1 is 14. 14. That's way too small. So I don't think the ones are going to work. In fact, none of the negatives are going to work because we can't have negative numbers. We're going to get a positive here, so it means we can't have negatives. So it's only the positives. So that means we should start with some. So let's randomly pick a few. If you use a calculator, you find out that some numbers like 4 do work in here, plus or minus 4, plus or minus 5. And 6 would work in it too. So 7 doesn't go into it, but we have a few here that we can start with. So let's do synthetic division to see whether or not one of these numbers here is a perfect 0 for it. And then that would enable us to see if we could put it into the polynomial, meaning into the 3 dimensions, to see if it would get 330 cubic feet. So if I do long division with a 3, I have the coefficients of 1, 7, 6, and negative 330. 1, 7, 6, negative 330. Bring the 1 down, multiply, add it to make 10, multiply it to make 30, 36. 3 times 36 is 108. That does not make 0. Well, I should have said what does, well, I don't even know what it comes to, but it doesn't matter. It means this one's no good. So let's do it with 4. 1, 7, 6, negative 330. 1, that's 4. That's 11. 44. That's 50. 50 times 4, that's 200. I'm getting a little closer here. Okay, that gives me what, negative 130, but that still doesn't matter. So it can't be 4. Let's do 5. Maybe 5 will get us closer, and maybe 6 will get us equal to it. 1, 7, 6, negative 330. 1, 5, 12, 60, 66. Oh, 5 times 66 is 330. We get a 0 here. That means 5 is a good number. Now, why did I pick 3, 4, and 5? Simply because it seemed like these might be reasonable numbers to try. Sometimes you think, what makes sense? Numbers that are too large wouldn't work. Like if I put 10 in here, I'd get 10 and 16 and 11. And I have 10 times 10 times 10. I'm over 1,000 right there. So I know it can't be as high as 10. So it has to be, whatever x is, has to be less than 10. It's got to be more than 1. So somewhere in that mix, and it can't be negative. So we've arranged that or figured out that it's a 5. So let's see if that works. Okay, if I put the length as 5, then the width would be 6 plus 5, which would be 11, and the height would be 5 plus 1, which would be 6. So if I do 5 times 6, I get 30 times 11. That is indeed 330. So that means that the dimensions are 5 feet by 6 feet by 11 feet. Because those dimensions will give us the 330 cubic feet that the volume is. So you see that what this question took was making sense of what, or remembering first, the simple, relatively simple formula that volume is length times width times height, but then making sense of the wording in the problem. In particular, this wording that the width is 6 feet more than the length, and the height is 5 feet less than the width. Those two, that gave us this and this. And recognizing that the length would be the x first, because the width depended upon the length, width came from the length, and the height came from the width. So the length was the foundation of the whole thing. If we know the length, we can put that into the width, and we could then put that into the height. And starting off with, we don't know it yet, so we use x for it. So there's one good example of how you end up getting a polynomial by using the variables with the information you know. Notice how I multiplied all this out and then I moved the 330 to the other side, okay, by subtracting it from both sides. And that gave me a polynomial. Because it's equal to 0, that means there were 3 possibilities that would make it 0. Well, in this case, there's one real one, and the other 2 would be imaginary here. Now, if I took this and put it into the quadratic formula, I'm pretty sure I would be getting an imaginary number. I don't even need to go that far, because 5 gives us what we need to get 330 cubic feet. Now let's take a look at a practice problem. This is the same type of idea. Why don't you pause the video and try to do it yourself, and do it first for a few moments, and when you're ready, come on back, start the video, and I'll be working on it. All right, welcome back. Let's take a look at the information. 11 over 20 cubic feet. The width is 2 feet less than the height. The length is 4 feet more than the height. Seems a little different in that both of them are based on the height. So the height will be my x. The width will be the height minus 2 or 2 minus the height. 2 feet less than the height. So that means if the height's 8, then the width is 6. If the height's 10, the width is 8. If the height is 20, the width is 18. So you have to take 2 away from it. And then the length is 4 feet more. That's easy. When it's subtraction, you have to think about it a little more. But here with multiplication, with adding, it's easy to say h plus 4, 4 plus h. So we now know, and we do know that the volume is length times width times height. So it tells us 1120 is the volume, and that's equal to, and oh, I put h when I should be putting x's here. So let's make these x's now. It's much easier, in my opinion, to work with x's. So that's x plus 4, x minus 2, and x. 1120 is equal to, let's multiply these out, x squared plus 4 minus 2 is plus 2x minus 8x. 1120 is equal to x cubed plus 2x squared minus 8x. 0 equals x cubed plus 2x squared minus 8x minus 1120. So carefully check my negatives, because I have a negative here and I follow it through, and that's the right negative. And then this one's subtracted from both sides, so it's minus 120. Now, the possible things we have, 1120 is P, and then Q is 1. So that does help in that I know that all I have to do is all the possible, if I have P is 1120, and then Q is 1, it's plus or minus all the possible ones for that. So that means it's going to be plus or minus 1, plus or minus 2, plus or minus 11, 20, 13. I believe 3 goes into it, plus or minus 4. Oh no, 3 does not, but 4 does. 4 plus or minus 5. So there's a whole bunch of them that we can do, and it's a large enough number. You think about it now. Just think, remember now we have 1120. I'm just going to play with the idea. If I did 10 times 10 times 10, that would be 1,000 right there. Okay, and that means I need to think about the numbers around there. Now this is plus and minus, so that means it could be, I think we're going to play with like 8s, 9s. Let's start with a 5, and then I'm going to try a 7, see if I get closer, and then try 10, and then maybe try 12, and then if I get over it, then I'll come back down to the ones in between. So let's do synthetic division with a few different numbers and see what happens. So this 5, 10, 12 would go into that 2, or also, I believe. I'm not sure. Would 12 go into 180? No, I don't think that 12 would. So we'll go this far. We can check other ones after 10 if that doesn't work. So with a 5, I'm going to use the 1, 2, negative 8, and negative 1120, because I'm taking these coefficients here and the constant at the end. So bring the 1 down, that's 5. 5 plus 2 is 7. That's 35. And then that makes 27. And we multiply that, it's 135. I don't even have to go any further. I know that's no good. So now let's do it with, say, 7. 1, 2, minus 8, or negative 8, and negative 1120. So 1, 7, that's 9, that's 63. That gives me a 55. Oh, that gives me 350, 385. So it's up from the 135, but it looks like I still have a ways to go. It's definitely not still 7 because we don't get a 0 there. So let's do 10. 1, 2, negative 8, negative 1120. So bring the 1 down. That's 10. That's 12. That's 120. That's 112. 10 times 112 is 120. And when I add them, I get a 0. So this is a 0. That's a perfect factor for it. So if that's 10, let's immediately plug it back into these and see whether or not it works. That means I would have a height of 10 and a width of 8 and a length of 14. So 10 times 8 times 14, if I multiply those, that does indeed equal 1120. So since that's 10 feet by 8 feet by 14 feet, this is feet cubed. And those are our dimensions. And I believe the question asks us for the dimensions. So the dimensions are 10 feet by 8 feet by 14 feet. And that works very well to make a polynomial based on the information that's given, find the possible factors, and then check them with synthetic division until you find one that is a true factor, and see if that works with the variable x to correctly come up with 1120 feet cubed. And it did indeed. So these give a couple examples of how to use it and practice using it. Focus on the P and Q, and when you don't know and you're not given a possible 0 to work with, then you have to make your own by using P and Q. And that's a major part of solving polynomials. Hope this was helpful. Thank you for watching.